Next, nature of curve. We are going to see nature of the curve parabola. From that we can easily trace the curve parabola, right? If y is equal to 0, then 4ax is equal to y square, that is equal to 0. So that implies x is equal to 0. So passes through the origin O 0, 0. If x is equal to 0, then y square equal to 0, right? That is y is equal to 0. Hence y is equal to 0, that is y axis is the tangent to the parabola at origin 0, 0. If p x comma y is any point on the parabola, since a greater than 0 and y square is equal to 4ax, therefore x greater than or equal to 0. Therefore y is equal to plus or minus root of 4ax, that is plus or minus 2 root ax. For any x greater than 0, we will get two values of y of equal magnitude and opposites in sign. Magnitude means root of 4ax. Opposite in sign means plus or minus, right? There are two values, right? So therefore the curve is symmetric about x-axis, and the curve lies in first quadrant and the fourth quadrant plus minus, right? First, second, third, fourth. Since x greater than or equal to 0 and p x comma y lies on the parabola, the curve does not exist on the second and third quadrants, that is minus plus and minus minus. So if you are having the x-axis and y-axis, so first positive side, that is right top, then left top second, and the line, the quadrant below the x-axis, that is left below, right? Bottom, left bottom, that is third quadrant, and the right bottom is the fourth quadrant, right? That is, the curve does not exist on the left side of the y-axis. Fourth one, if the value of x increases infinitely, then the two values of y also increases infinitely in magnitude. If x tends to infinite, then automatically y tends to. So the two branches of the curve lying in the first and fourth quadrant, that is opposite sides of x-axis, right? Extended to infinity towards the positive direction of x-axis. It will go extended, right? Hence it is open curve. So this is x-axis, this is y-axis, this is the origin. So curve will be open, right? This is the first quadrant, this is the second quadrant, third quadrant, and fourth quadrant. So curve exists only in the first and fourth. There is no trace of curve in second and third. Chord. The line joining any two points on the parabola is called chord of the parabola. If p x1 y1 and q x2 y2 are any two points on the parabola, right? 2 points. Then pq joining the line p, the points p and q, you will get the line segment. Here line pq is called chord of the parabola, right? Next, focal chord. A chord passes through the focus is called focal chord, right? Simple definition: x-axis, y-axis, origin. This is the parabola. Let S a comma 0 be the focus of the parabola. P x1 y1 and q x2 y2 any two points on the parabola. Then the line joining PQ passing through the focus S is called, this is the focal chord. Here PQ is the focal chord. Double ordinate, the chord passing through any point on the parabola which is perpendicular to axis of parabola is called double ordinate of the parabola. So if you are taking a parabola, let S a comma 0 be the focus and P x1 y1 any point on the parabola, right? So this is x-axis, right? X-axis is nothing but the axis of the parabola because it contains the focus of the parabola. the line passing through P and perpendicular to the axis of the parabola, right? So this is the line, right? That is called double ordinate of the parabola. Latus rectum, the double ordinate passing through the focus is called the latus rectum. Suppose the double ordinate passes through the focus, yes, then it is called the latus rectum of the parabola, right? So this is the latus rectum. The double ordinate passing through the focus, right? That is the line passes through the focus, yes, and perpendicular to the axis of the parabola is called latus rectum of the parabola. Length of the latus rectum of the parabola y square is equal to 4ax. Let a comma 0 be the focus of the given parabola, y square is equal to 4ax. Let L dash be the latus rectum of the given parabola, right? So yes, so this is the latus rectum. Clearly x coordinate L of L and L dash respectively A, right? So O is the origin, so OS is the x distance of L and L dash, right? So both are same, OL which is equal to OL dash equal to A. Y coordinate of L and L dash be y1 and minus y1 respectively, because L dash lying on the fourth quadrant, so negative y, positive x, but L is lying on both are positive x, positive y. So we are taking that coordinate, y coordinate of L is positive y1 and L dash is negative y1, because same distance, right? Y distance are same. For SL dash is equal to SL, right? That is why, because symmetric parabola is, so the above the part above the x-axis is equal to the part below the x-axis for the curve, under the curve, right? Y distance from origin to L and L dash, SL equal to y1, SL dash is equal to minus y1. So L is a comma y1, L dash is a comma minus y1, right? Since L a comma y1 lies on the parabola y square is equal to 4ax, so L a y1 satisfy the equation y square is equal to 4ax. So put x is equal to a, y is equal to y1 in y square is equal to 4ax, you will get y1 square is equal to 4a into a, 4a square. Therefore y1 which is equal to plus or minus root of 4a square, that is plus or minus 2a. So SL is equal to y1 equal to 2a. So L a comma y1 which is equal to L a comma 2a, and L dash a comma minus y1 is L dash a comma minus 2a coordinates, right? So length of the latus rectum L dash which is equal to 2SL, 2 times, because both are same, because SL plus SL dash is equal to SL, so 2SL, so 2 into 2a 4a, which is the length of the latus rectum of the parabola. If the length of the latus rectum is known, we can easily find the standard equation of the parabola. So from length of the latus rectum you can find a, right? From, if you know a, then y square is equal to 4ax. Substitute a there, you will get the equation of the parabola. Thanks.